Okay, great. So why don't we get started? Welcome, everyone. This session is the session for engineering students who are interested in engineering management, as well as students who are undecided about an engineering program. That's not exactly a negative. That's actually quite a positive to say, I don't know which one I'm interested in. So can you help me understand which one is best suited for me? I have with me Joan Sarles, who is our first year professional advisor, and Dr. Paul Nowak, who is a civil engineering professor, and they will both introduce themselves. And as you have questions, you have two ways we can address your questions. One is, of course, you can unmute yourself, and I think there may be even a raise hand thing out there that you can raise your hand or just say, I have a question. The other one is to type the question in the chat for us to see it. And, every question that we have come across, you might say, I'm the only one with that question. Turns out almost everyone has the same question. So please don't hesitate. I'll keep the number of slides to a minimum, but I'm hoping that these slides will help to motivate some of the discussion. Okay, here we go. And I guess I should first try to share my screen. Okay, hopefully everyone can see this screen. And then play from start, hopefully this thing. Okay, so it's going to be very, very simple, not a lot of slides. So Paul, would you mind unmuting yourself and say a few things followed by Joan?
Sure, I get to go first. I've been here for 27 years at Gonzaga. I'm the Associate Dean of Engineering, and I'm also Professor of Civil Engineering. I grew up in Buffalo, New York. They asked for a fun fact. I don't know how fun this is, but I've been married to my wife for 36 years, 4 children and 7 grandchildren. And I have 2 children that are GU alumni. One graduated in civil engineering back in 2013. Another one just as a general liberal arts in 2017. And I got one more in high school that's looking forward to attending and following in his brother's footsteps in civil engineering.
Thank you, Paul. Joan? Unmute yourself, Joan.
There we go. Sorry about that. This is Joan Sarles here, and I've been at Gonzaga for about 20 years now. And my son graduated in 2017. I am the first year advisor primarily. So those of you coming in, I will be working side by side with you to help you figure out your degree plan for the next 4 years. Crazy fact is, before I started working at Gonzaga, I worked for my brother, who was a general contractor, and they called me Tink the Mighty Hammer.
Thank you, Joan. Okay, for those of you who are in the category of undecided or undeclared engineering, typically what happens is that you have 1 year to declare a major within the School of Engineering and Applied Science. We have what's called a common first year experience, even for the students who know which majors they'd like to really drill down in. And so everyone's put into the same first year engineering seminar. It's a 2-course sequence, one in the fall, one in the spring, and we try to introduce you to all the disciplines. This fact probably will not surprise you though. It's some students who come in saying, I want this kind of engineering. After sitting through a first year engineering seminar, say, well, maybe no, maybe this is a better engineering discipline for me. So switching around is not something that's uncommon or new to us. And it's something we hope you do in the first year. So you settle in for the next 3 years with us. Our faculty are eager to discuss their areas of expertise. I will tell you right now, each of our faculty in the different engineering programs will say this to you: my engineering program is the best. And that's what they should do, because that's why they majored and not only got their undergraduate degrees, but their advanced degrees in that particular expertise. And you'll find that many of our faculty also went out and practiced their disciplines before returning to be educators at the university. Dr. Noack will tell you that he has a professional engineering license, and he continues to practice and consult in his area of expertise in civil engineering. The faculty are here to, if you're still unsure, you can actually Google what do engineers do, and from that source, again, align what you read to what our faculty are telling you about the individual engineering programs. Engineering management, which is a specific discipline inside of the School of Engineering and Applied Science, has a business minor track built in. The students take 21 credits in the business school and end up with a business minor. But in the meantime, the engineering management program, they also are able to drill down into one of the existing tracks, including computer science. So the engineering management program is actually built around the different engineering as well as computer science program. The student takes a concentration in a certain area, but adds the business minor on top of it. And so you're building engineering, management, and leadership skills to lead engineering projects, short-term and long-term, as a first opportunity when you graduate with your degree. And the educational concentration we give you allows you to enter the MBA program at Gonzaga and complete your MBA in additional year. So if this track is for you, you know, the big picture in one of the areas, plus the business minor, with the potential of getting an MBA, then you have chosen the right field. It's called engineering management. We have something called the pre-engineering pathway. They take the same courses as those who come in direct admit, we call them. You sit through the same first year engineering courses. You take the same chemistry courses. We teach you critical thinking. We have our core broadening courses that are aligned with our university's mission. And of course, you take the same mathematics. The difference is that when you enter, your high school experience may not have given our admissions professionals a big picture that you have the necessary, what we call pre-calc skills, as well as enough introduction to science that we feel that you can jump directly into engineering. You might say the pre-engineering pathway is our way of saying, if you want to be an engineering major, we want to set you up for success. And what is success? To move from pre-engineering to a direct admit, you need to earn a 2.0 or a C or better when you take our first semester of 16 to 17 credits and get no Ds in any course. And you have to earn at least a C in our pre-calculus scores and a C minus in Calc 1 and Calc 2. These are our indicators that you will be successful in engineering, because the engineering program is not a trivial program to major in. And our intent with the direct admits as well as the pre-engineering admits is that you graduate in 4 years. So you may have to take a summer course to catch up on your math or to stay on track with your cohorts. Another way to think of this is that some of our students come to us from places where they did not have an opportunity to be engaged with calculus or physics or chemistry through no fault of their own. That doesn't mean they can't be an engineering major. And we want to give those students who, through no fault of their own, did not have this experience, who really can be the most wonderful engineers. Let's give these students an opportunity to do that. Again, we are about students being successful. So here are some ideas of what happens in the common first year. You get exposure to all our engineering programs. We give you studios called hands-on learning. They're not quite labs, but they're studios. And some of the projects that are here, the students will be exposed to in teams. Robotic programming, circuit design, solid beam design, and pump performance. These are just some examples. The pump performance monitoring ties more closely with mechanical engineering. Circuits design and control ties more with electrical and computer engineering. Robotics programming may also tie with computer engineering, and solid beam design may be tied with civil engineering. Again, we're about student-centered. We put you in cohorts that make sense so that you develop peer relationships. And for the first time, we're putting you in teams because our workforce tells us that, industry tells us that when you actually go out and practice your discipline, you're not doing this in a solitary, you're doing this as a team, working with other kinds of technological areas. And I'm going to close with the fact that you start with studios in your first year, you will end with your senior design projects. And this year we had over 60 senior design projects. We partnered with 35 industries in our community, including the industry as far away as Seattle. And that of these 60 senior design projects, students do define their own projects because they have been exposed to other ways of learning, for example, through undergraduate research experiences or close ties with the faculty doing some kind of independent study. We also have what's called Innovation Saturday, because we also want to expose you to how you can take your ideas, your creation, turn it into innovation, and potentially take that innovation into some kind of prototype or proof of concept. That's a natural track for an engineer to think about. You think about, what am I doing? But you also ask, who will it impact? And knowing my community, how will they use it? This is the other piece about what we do, is thinking about societal impact. We also are very proud of the fact that our faculty do advise our students after their first year. And as Dr. Noack will tell you, one of the things about advising is not just advising about what classes and making sure that you're on track to graduate, but our faculty are actually going to help you, if you're willing to let them do so, to help you with your career trajectory and, as Dr. Noack will say, and life, navigating life in general, because these are those very formative years when you are in college. Either you're going from ages 18 to 21 or 19 to 22. These are some of your most formative years, developing your character. Okay, we also want to brag about our facilities and lab spaces. We have some very common facilities and lab spaces. You can see some of the heavy machinery that our students are exposed to. And one of the most important things is also the practice of safety. I notice the safety goggles on the students, and we're always making sure that our students are certified to work in our labs. On this side is what we call the Students Fabrication Lab. This is where our senior students go and do fabrication of their different prototypes. And then once again, they're working in teams and they're practicing safety and risks mitigation. I'll stop there and ask for questions. And the questions, I may not answer these questions, but Dr. Noack and Ms. Charles Joan will do their very best. So that's all I have to offer. And so this is the time when I'll end the show. I will stop sharing the screen somehow. I hope it stops sharing. Stop sharing the screen and open it to questions. And thank you all very much for joining us and for spending the time and listening to us. The floor is open.
So I just have a quick question about computer engineering and computer science. Like, computer science, is that the coding part, and then computer engineering, like the actually building the computers, or what's the difference there?
That's one of the differences. Computer science is more the programming aspects, the language, the algorithm development. Computer engineering, think of it as taking that same instructional set and putting it on the chip inside the computer so that the instructions are embedded and are optimized for that particular platform. Computer engineers work more closely with electrical engineers because of the circuitry, you know, the semiconductors or the chips that are in there. The computer scientists do more on the interface and the use of the machinery. Dr. Noack, would you want to add anything to that?
No, I say that's a good overview from what I know. It's not my expertise, but I would say that computer science is more of the theory end of it, and the computer engineering is more the application and getting it into the use of the hands of the consumer.
And that's also kind of the way we look at science and engineering, right? Science may come up with the actual initial creation. Engineers think of who can use it. We apply it. We ask, how do we scale it? What size do we need? What's our intended audience? That's sort of the interface between the two.
Thank you.
You're welcome.
Somebody's got to chime in. I've been done this before, and lots of questions will come up. Will everybody graduate in 4 years? And the list goes on and on. I'm not going to ask the questions and answer them for you, but there's going to be something to prime the pump here so we can get going, because I know you've got lots of questions since you're here today.
Hey, Paul, I got a list from Aaron. These are questions that students sent in when they registered for the webinar. So I'll just throw a few out there, okay? Are there core subjects that would be replaced with engineering classes? If so, what are these? I guess I can answer that one. In your first year seminar, if you're an engineering major, that takes the place of the core requirement for English 101 English composition and the core first year seminar. It also covers intro to engineering and some programming and some group projects, as Dr. Who mentioned. So those are the core courses that are covered by that one-year sequence, your first year. Then in your senior year, you have a senior design project, as Dean Who mentioned, and that senior design project also covers another writing requirement. Fine art and design is included, the design aspect, as well as communication. So there are some core courses that are covered within our engineering curriculum. Let's see. Is it common for electrical engineering majors to also have a minor? Anyone want to take that?
It's not surprising that
I'll jump in because somebody just, I'm not a computer expert, but there was a question that popped up on the screen. If you're undeclared and then have to declare, what's the process and how long does it take? As long as you do that in your first year, you're right on track and you shouldn't have any issues. The longer you wait, some of the classes you may be missing as prerequisites start building up behind you. So you've got 1 year to do it. The actual process takes at least 4 minutes. So we can transfer you over pretty quickly. It's a painless process, but you've got a year to decide, and that's why we have lots of resources to help you make that decision.
Let me add to that. There are many opportunities for the student to approach the faculty, for example, Joan, and say, I'd like to talk some more about, let's pick on what, civil engineering versus mechanical engineering. And then Joan will probably make an introduction to one of the faculty in those disciplines to have the students spend some more time unpacking what is their affinity for civil versus mechanical. And there are some very big differences. Another way we unpack it is the faculty would say, would you like to study heat transfer versus would you like to study concrete, right? You can see that that's a very different conversation. And the other thing that the student will encounter is in our studios, we try to put the projects in the studios that are aligned with some of the engineering disciplines. So the civil engineers may have an exercise on dams, building and structures, while the mechanical engineers may have a studio on pumps and paddles. And so they're very different things. And so we're trying to help the students both through conversations as well as actual doing to help them decide. And a third way that we sometimes help the student decide is to pair them up with an upper level student in that area, because sometimes students relate to students better than they relate to their faculty. So thank you for that question. But Dr. Nowak is right. The sooner you declare, the sooner you get on track and not miss a beat in trying to get done in 4 years, which we pride ourselves on. So thank you very much for that question.
Let me piggyback that because I get this question a lot. And Dr. Who put up a slide in the introduction that said, if you're not sure what you want to do, one of my recommendations is just go Google what the different disciplines do. If nothing else, it may help you eliminate some of your choices as opposed to honing in on one, because there's lots of crossover between the engineering disciplines. So that might be a homework assignment you can spend an hour or so on just searching the web. It might help you refine your decision.
And occasionally, a student will double major. I've never seen a student double major into engineering, but it would not be unusual for someone like an electrical engineer to double major in mathematics, or someone in computer engineering to want to double major in computer science. It all depends upon the student's affinity and what their interests are. Here's another question. If we have taken pre-calc but not calc, would you recommend us doing pre-engineering? Or like, what courses do we have to take to jump into engineering major right away? Dr. Noah, Joan, which one would you like to take that question?
I'll take that one, and Joan, you can chime in from the tropics a little later. But my take on it is, if you're unsure of your math skills, if you get admitted to Gonzaga, what I will do is send you down the hall to the chair of the math department, and they'll ask you some candid questions, and you just need to be honest, and they can tell you exactly what math class you should be in. As for jumping into pre-engineering first, that you're either going to be admitted to pre-engineering or you're not. So you're not really going to have much of a choice. I don't believe in that matter. But for the math class, I would just ask you to be honest with the math department, and they do a pretty good job of coaching you which way to go.
So Dr. Noack, I don't know if you're aware of this. They did just instigate this policy that everyone, it takes the ALEKS placement exam the summer before they start. So the students right now, if they completed their survey with the academic advising and assistance, they'll be asked to take the ALEKS test. And the ALEKS is a great way for us to put you in the right math class so that you're not way over your head, but you are learning and improving your math skills. So I would advise each and every one of you to do that ALEKS math placement test and also complete your survey for academic advising and assistance as soon as you can, because that's really going to help you decide what you do this summer. And if you need to do a little, maybe at your community college near your home, or Gonzaga has online classes over the summer, you might want to brush up on your pre-calc, get that trig done so that you can start in Calc 1 in the fall, or bump up to Calc 2. Wherever you place, it's an indicator of where you legitimately should be. But strong math skills are the basis of engineering and computer science as well. So that's a great question. So if you could do something in the summer to help yourself, it's a great idea. You're free to email me once you have ALEKS placement and you want some help, figure out what to do with that. I'd be happy to chat with you about that.
Let me also add one other thing, is that if you have taken pre-calc, there's no reason why you ended up in pre-engineering. But that's not the only factor that puts you in the pre-engineering bracket. Our professional advisors look for other things, your exposure to other science and other factors that they weigh. In our own small way, what we're really trying to do is to make you to help you be successful when you come to Gonzaga. Joan is right. Math skills are going to be important, but they're not the end all to everything. But they certainly play a role in your success in completing our program. Thank you for that.
Since there's no questions, let me throw something out there for you, prospective engineering students. I have had lots of prospective students in my office asking me with their parents, and should I do engineering, what discipline? The only question I will ask the student that wants to come in engineering is, why do you want to be an engineer? And if I hear it's good for society or makes a lot of money or this and that, that's fine and dandy. But what I want to hear, if you want to succeed, is that you like math and science. And those are the strong suits that you've got coming in. It's a rare bird that I find that comes into engineering that likes math and science and English. But some of you like all three. That's a real gift. But if you don't like math and science and you struggle with it, I will caution you that it may be a struggle to jump into engineering up front.
So while you're all thinking of other questions, Joan's right. We had a list. Here's something that a question I'll throw out that you may be interested in. You may ask, do students get any research opportunities? If so, what kind? Dr. Noack, would you like to take that one about research opportunities?
Yeah, there are over half the faculty do research with undergraduate students. Interest in a particular topic and doing some undergraduate research, I would encourage you to start knocking on doors and talk to specific faculty in the departments of what they do and could you hook up with them. And then once that goes, that gives you 4 years to develop a really good plan. You may end up with a nice paper and project or even a senior design project to the end of your 4 years. So if you have that interest in your repertoire, then start knocking on doors and ask questions.
I'd like to add a few more dimensions to that young students are unaware of. And it's about these opportunities to work with the faculty. In the end, when you're looking for an opportunity, you will turn to your faculty and say, for example, Dr. Noack, could you write me a letter of recommendation? Could you say to a potential employer out there what kind of student I have been? And so, if all Dr. Noack can say about you is you took my statics class, you took my construction class, and you did fine, that's not saying very much about you. So we couch these one-on-one experiences with our faculty as research experiences, but in some ways it's much more than that. It's a way for you to get that supervisory opportunity with our faculty to learn something more deeper about your profession, and vice versa, for the faculty to help you to develop innovative thinking, how you question things, how you develop along a certain line of inquiry. Remember, we are about developing your problem-solving skills, your critical thinking skills. And by having that one-to-one supervision, not just in the classroom, but in a different setting, working with the faculty in their laboratory, working with the faculty on a publication, a paper, an idea, it gives the faculty greater insight into your personality and your character. So should they have to say something to a potential employer about your capabilities, they can say it with a great deal of confidence because they've gotten to know you in a different dimension. That's something for you to think about at an early stage in your career. Many of our students finish their 4 years, and while we know them to some extent, we don't know enough about them to write a very strong letter of recommendation that says, unequivocally, this student can do so and so and so and so. So that's something to think about earlier on in your development in college. Any thoughts about that from anyone? Very quiet.
So like, if I was getting into engineering for like to build an Iron Man suit, what would you say would be the best track to go? Just in theory.
To build an Iron Man suit.
I love
Dr. Noack, I think you should take that one while I think about it.
You better double major.
That's very fair. All right.
Joan, any concepts on the Iron Man suit?
I think that's fantastic. What a great idea. But definitely it hits on many different disciplines. But, you know, there is some crossover, as Dr. Noack mentioned earlier. I mean, there are mechanical engineers who are working in other fields. So, you know, people who are curious and smart and they have a great skill base to build on, anything's possible.
Yes, someone suggested, Charlie, that maybe you should consider mechanical engineering and art.
Yeah.
Right? Fine arts, to design that thing and make it work. I think that that's a wonderful suggestion. Thank you very much. And there are so many opportunities in our core broadening courses for our students to be exposed to fine arts and design, to literature, to world religion. We take a very strong stance that our students have those broadening skill sets. So we will teach you the engineering and computer science fundamentals, but we will not hesitate to give you the skill set in writing, in speaking, in social justice, in those things that underpin our Jesuit mission. And I hope you'll understand that that's what gives you that broadening experience that complements the very technical skill set we're trying to impart to you. Here's another question that, here's somebody asking a question. I'm keenly interested in data visualization and thinking. This might be a computer science base plus another discipline. What would you say to that, Dr. Noack?
For the Iron Man suit, or I'm?
No, the chat session that the person wrote. I'm keenly interested in data visualization, and I'm thinking that that might be more computer science based plus another discipline.
It's probably computer science and computer engineering. It may be some art, but yeah, that's a good one on. But computer science or probably computer science would be.
That's right.
I'm thinking.
We have definitely some courses in the computer science department that deal specifically with data visualization. And it's not, you know, a major unto itself. It would be part of some of the upper division electives that you take within a computer science degree.
Yes, I would add to that, data visualization could also encompass graphics, right? And we do have some, it's in computer science. But in addition to that, there's an old word that we normally use sometimes for that. That is the study of statistics, which means that you could be interested in perhaps a minor in applied mathematics in our mathematical department, where again, the concept of visualizing data, whether it's in model form or graphic form, would probably lend itself to understanding something about the statistical nature of the data set. In today's knowledge-based economy, data analytics, data informatics, visualization of data, computer modeling, those are indeed areas in which our students and our faculty are interested in exploring. I hope that's a little helpful. Here's another question that could get your interest is, what's something that most students should be most prepared for during their first year? What do you think, Dr. Nowak? What would you say you wish you knew then that you knew now to help our students be prepared?
I think your best avenue is to get over the fear of coming to faculty's offices and for support, because I never know what's going to happen. And when I used to talk to all the incoming freshmen, and I share the story of my son when graduated from high school, and at the ceremony, it used to be when I was in high school, there was one valedictorian who had a GPA 3.7. But now I see the whole front row or 3 front rows stand up with valedictorian. You're no longer in Kansas. You're in a different avenue that you're going to have, probably need some support mechanisms. And I would suggest that you just start going into some faculty's offices and introduce yourself. And I have an incentive. I teach a freshman class, and I tell all the students, I have a jar of nickels on my desk. And if I don't know your name, I'll keep giving you nickels until I do. And get over the hump of the fear of going into these faculty's, professors' offices. But I would encourage you that the main reason most of us are at Gonzaga is because we want the students in our office, as opposed to a large state school where you've got 600 people in a chemistry class and faculty don't have the time to chat with you.
Here's another question. Are the 3 laptop choices for the C's the only choices we have? Or are there certain things that the laptop needs to have? Let me take that one. We discovered this past spring, when we had to go to digital distance learning, that some of the laptops our students had could not accommodate the software that our students needed. So that means that when the students were on campus, we had set up certain computers, a minimal number of desktop computers that could host the software. But suddenly the software needed to be put on the student's laptop. And we found that there were limitations in some of the laptops we allowed students to have to bring to campus that did not fit our requirements. So it is an issue for us that you try very hard to bring the laptop with the specifications that we have asked you to do so. You can imagine that if we had to put a piece of software on your laptop and it ran so very, very slow, how frustrating it would be for you to be able to work with that piece of software. The flip side, though, is you might ask, why would the faculty want me to use a piece of software that would run so slow on my platform? What we're trying to do when we choose the kinds of software we want you to use is because we want to make sure that you are prepared with the latest technologies when you go into the workforce. What's the favorite computational tool that we use among the many disciplines? It goes by the name of MATLAB. We would not want to not educate you in MATLAB, so when you go out into the industry, you are not competitive. So that's why we have been very specific about what our laptop choices are, especially in engineering. In computer science, it's different. In computer science, they actually don't mind using 3 operating systems. They are open to using the Windows system, they're open to use the Mac operating system, and they're also open to using the Linux system. But that's the very nature of the computer science. In engineering, remember, we are applied, and we clearly want you to be equipped with a laptop that's not going to frustrate you as we continue to embrace the newer technologies and sometimes the larger software platforms out there. We just are trying very hard to make you as competitive as possible when you leave us here at Gonzaga. So it's not that we're trying to be so restrictive. We are trying to be too helpful in our own way. I hope that helps a little. Here's another question. What type of students pursue an engineering management degree? What an excellent question. Dr. Noah, Ms. Charles.
My take on that is, if you want to get in the nitty gritty of all the design details and designing all little pieces and components and parts and cars and bridges, that's the engineering. If you want to be the project manager that puts the different disciplines together, the business part, and kind of oversees in a grand scheme of things how the projects are run and organizes them, kind of as a leadership to put the pieces together and put the right engineers with the right business people and the right clients, that's what the engineering management people do. They're an overseer of the project, and they're not so much in the nitty gritty of the details of the design.
And I would add to that is the, I'd like to think of the engineering management student who looks at the menu and can't decide if they want steak or lobster or pasta. And they say, why don't I try all three to some extent? I'll take a bite of this, 2 bites of that. But in the end, they see that in order for these 3 different types of menu items to be there had to be a greater picture. And that's usually the picture that underlines the resources, the accounting side, the planning side, the financial side, the operational side. And the student says, I'm interested in not really the specifics of the menu item, but how the menu items were actually chosen and put together. What was that process, and how do I manage that? That's that extra dimension that some students really come in with and enjoy learning about the fundamentals of mechanical engineering or the fundamentals of civil engineering, but not to the extent that they want to drill down in their junior and senior year into being just that kind of engineer. They actually think about it from a project operational standpoint rather than from the nitty-gritty detailed design standpoint. So I hope that helps you. And we find that our engineering management students, their vocabulary is actually probably the richest when they're finished. They're not the deepest, but they're the richest across the different disciplines. Okay, here's another one. Do you guys offer chemical engineering? Sadly, no, which is what I am. Chemical engineering is a very expensive engineering discipline. That if we had to do something along those lines at Gonzaga, the closest I could think of is materials, because materials would involve chemical synthesis or biochemical synthesis and characterization, which is that piece, that's the engineering piece. So the chemical engineer usually has a really strong background in chemistry and reaction engineering and organic and inorganic chemistry, but they didn't become a chemist. They became a chemical engineer because they also wanted to apply the characterization and the mathematical analysis, mathematical modeling to what they're trying to do. So the short answer is, the real answer is no, we don't offer chemical engineering. The next answer, though, is if we did offer something along those lines, it would be more closely aligned with material science, materials engineering. And we do have faculty with that expertise here in the School of Engineering and Applied Science. Other questions? Here's another interesting question that I'll throw out there. It says, after looking over other programs, I find that yours offers a 4-year plan that is attractive to students that would like to graduate early. My question is, how is Gonzaga prepared to shape students into a high standard of education? The question is, how is Gonzaga prepared to shape students to a high standard of education? Dr. Nowak, any insights in that?
Well, first of all, if maybe I didn't hear you right, but we typically do not try to get students out in less than 4 years unless they come in with some credits up front. That's just too much work to get it in with the scheduling. And if you saw Dr. Hoo's introduction to the original, I would say it's the Jesuit education that makes a huge difference compared to other institutions. And I believe that's why alumni and employers will come back with the surveys we send them, that we are more prepared than peers at other institutions. I'll share a little story with you. I worked for a consulting firm one summer, and the employer came to me, he was taking a class from me, and he said, you know, we hire these students from Gonzaga and they don't make me any money. But we hire these students from the trade schools and they make me a lot of money. And I thought, oh, you know, A, thanks for telling me. And B, do you still hire students from Gonzaga? And he said, you bet. What happens is Gonzaga has trained the students to be so well broad-minded. They're not detail-oriented, but what happens in 3 years, they are running projects for me. They are meeting with clients. They're running the show. So it's an investment that's well spent from his point of view. So it makes a big difference from the product coming out of Gonzaga versus somebody or a school that really doesn't have a focus on what they're trying to graduate as opposed to just credits.
I think I'll follow that with, thank you for that, Dr. Noor. I think I'll follow that with, you know, if the students weren't so in a hurry to finish in 4 years, what else could they do if they were to finish in on the average, let's say 6 years, which is the national average out there? I'd say the student then would find so many other opportunities to take the technical electives that we offer. You know, we have small student to faculty ratio, small classes. And so, and we teach our classes often. And so, you know, if indeed a student doesn't mind finishing in more than 4 years, there'd be opportunities for independent study and taking more technical electives, because what the purpose of the technical elective is not that they have been in the curriculum for years. It's that our faculty are creating these technical electives because that's the need they see in their discipline. For example, if you were a computer science or computer engineering major, let's take a computer engineering major, and you said, geez, I came in with AP credits, I'm moving so fast in my program, I have room in my program to take a technical elective. What's a good technical elective that would be just in time for my graduation? It's not something that's old. And the one that comes to mind that's very prominent right now is cybersecurity. Cybersecurity was not on the books 8 years ago. And cybersecurity has taken on a whole different dimension. And so somebody who's in computer engineering might say, and a faculty who's interested could develop a technical elective in cybersecurity. And so the student would be able to take cybersecurity in their program if they have room for it. But that's what a student could do if they had room in their program or they wanted to finish, not in a hurry to finish after 4 years. But that's something to think about is what could separate our students is that if they came in with all these credits and were moving very fast and still had time, did not want to leave in 4 years, we offer cross-disciplinary technical electives as well, for example, in environmental studies, that could broaden the student in a different direction. So that's something I think that other schools offer these technical electives, but the way we structure a program so well that only there's only certain times in the program that they have time to take a technical elective. So that's sort of where I think that question was going. Here's another question. My online schooling is very lacking. What online learning should I do to prepare for next year? Dr.
Hopefully none. I don't think the faculty here are enjoying online teaching. I'm one, and I'll raise my hand to it. We did it because we kind of got forced to do it, and we made it work, but that's not why you're coming to Gonzaga. So I wouldn't really spend too much time prepping. You're doing a good job just being here on Zoom.
Yeah, I think that when we surveyed our students about their experience, have been thrown in to the current situation of getting digital distance learning, and you ask them what would they want done differently, some might say, I wish I had better internet connectivity, more robust internet connectivity. Others will say, you wish I had a faster laptop or something to make my activities less frustrating. But one of the most important learnings I've heard from our students about their online learning is this, and that was really an interesting statement. The student said, when I have to go on Zoom, which is the platform we're using for online delivery, which is what we're on right now, I said, when I prepare to talk to my peers in a Zoom chat or with my faculty, I better be prepared to ask questions. I better be prepared. He said, when I was on campus, I didn't prepare. I met up with my cohorts very quickly and tried to get everything else together in 15 minutes before class starts. But now, when I have to do it online, I have to be prepared. And I make very good use of my time with my peers and my faculty when I have to learn in this particular mode. So a short answer to your question is, no one's ever prepared for the online in every facet. But if we think about it, we sometimes, out of necessity, we accomplish the most interesting things and we just try to make it work to the best of our ability. Someone said, since I'm going to shelter in place anyway, tell me about online summer classes to help me. Joan?
Okay, so yeah, online classes are pretty much de rigueur right now. Every college offers them, and many colleges have gone so far as to announce that all their summer courses will be online. And I think that is the case too with Gonzaga. So if you wanted to get started a little early and take classes through Gonzaga online, you can take core classes, you can take mathematics. So there's a whole bunch of different things you can do. If you, for whatever reason, wanted to do that at your local college, at your hometown, you can do that as well. I would say, keep it pretty simple. Take things, if you've taken a look at the curriculum for engineering or computer science, you'll see some common courses that are in our core. History, United States history, Western Civ. Of course, it does never hurt to keep your mathematics going because math tends to build on itself. So maybe take the next math that you need. But I'd be happy to help you if you're confused and you don't know what to take. Just shoot me an email. I can review your high school transcripts and see what credits you already have had, and we can figure out what you can do.
Well, we're at the close of the hour. I want to thank everyone for staying with us. And I hope that we're able to answer some of the questions you may have been thinking of, or others that you haven't. And as Joan said, as well as Dr. Nowak and myself, just email us. We are more than happy to try to provide a response. And also, it's not unusual for any one of us to actually have a follow-up conversation one-on-one with you. So while we might be emailing responses, sometimes a conversation by phone, a Zoom one-on-one will help to help us see where you're coming from and try to make sure our responses fit the question as we understand it. And I see that Dr. Nowak and Joan has provided their email address. Mine is ever so simple. It's hook@gonzaga.edu. I don't think you'll forget that very, very quickly. So we're at the hour, and I want to thank you all very, very much again for participating and for staying with us during this time. Dr. Nowak, Joan, any last comments before we
just gave my email and phone number there. I'm happy to chat with anybody or converse via email. So fire the questions away if we haven't answered what you like or you had here today.
Okay, thank you again. Have a very good evening or morning or afternoon, whatever time zone you're in. Again, we at Gonzaga in the School of Engineering and Applied Science, thank you so very much for your participation. Bye-bye now.
Thank you guys.
Bye.
You're quite welcome.